Ever wonder what happens deep beneath our feet when the ground starts shaking?
It's a fascinating and sometimes terrifying world down there.
This paper dives into a specific earthquake in China, MW5.5, that surprised everyone.
It was unexpected because the area hadn't seen a big quake in like over a century.
And no one knew there was a fault there. Let's unpack this mystery. So this MW5.5 earthquake hit Pingyuan County in China. What made it so unusual?
It was the location. No major earthquakes had been recorded there for over 100 years. Plus, there was no known active fault in the area.
Wow. So it was a complete surprise?
A total shock. The damage was significant too, with houses collapsing and people injured. Yeah, it was pretty bad.
How did scientists figure out what happened?
They used seismic data, P waves, S waves, from lots of stations around the epicenter.
Like a giant earthquake detective network?
Exactly. They used a technique called double difference relocation to pinpoint the quake and its aftershocks. Very clever.
And what did they find?
They discovered the earthquake happened on a previously unknown buried fault.
A hidden fault line? Seriously?
Yep, lurking beneath the surface. They determined its orientation and dip using the aftershock locations and the focal mechanism solution.
So what did they learn about this hidden fault?
It dips steeply to the northwest, with a strike similar to a nearby known fault, the Gaotang fault.
Interesting. So it might be connected to the Gaotang fault?
That's the theory. It could be an extension of it, a previously unmapped segment. Makes sense, right?
What about the actual rupture itself? How did the fault break?
The rupture was unilateral, moving northeastward and upwards from the hypocenter.
Unilateral? What does that mean exactly?
Meaning it only moved in one direction, not both ways. And it was relatively slow.
How did they get such precise details about the rupture?
They used centroid moment tensor inversion. This technique uses seismic waveforms to determine the earthquake's moment tensor, which reveals the type of faulting and the amount of energy released.
So they essentially reconstructed the earthquake's movement?
Precisely. They even estimated the rupture velocity and duration. Amazing, huh?
What were those estimates?
So the rupture lasted about 6 seconds, releasing a scalar moment equivalent to MW5.54. The initial rupture velocity was slower than the local S-wave velocity.
Slower than the shear waves? That's unusual.
It is. It suggests a complex rupture process. Yeah, pretty complicated.
What are the implications of this discovery?
It highlights the importance of understanding buried faults. They can be significant seismic hazards, even in areas with a history of low seismicity.
So we need better ways to detect these hidden faults?
Absolutely. This research emphasizes the need for improved seismic monitoring and hazard assessment. Definitely.
Did this study compare its findings to other analyses of the earthquake?
Yes, they compared their results with focal mechanism solutions from other institutions. There were some differences, likely due to variations in data and methods.
So this study provided a more refined picture?
A more precise and detailed understanding, yes. Much more precise.
So what's the big takeaway from all this?
The Pingyuan earthquake happened on a previously unknown buried fault, likely connected to the Gaotang fault. This highlights the hidden seismic risks in seemingly quiet areas.
And what's next?
More research is needed to better understand buried faults and improve seismic hazard assessments. This study is a crucial step in that direction, a very important step.
Anything else that stood out in the paper?
The relatively slow rupture velocity was intriguing. It suggests the fault might have some unusual properties.
Something to investigate further.
Definitely. It could lead to a better understanding of earthquake mechanics. For sure. This research really underscores the importance of continued seismic monitoring and research to better understand and mitigate earthquake hazards.
That was a great discussion. Thanks for sharing your expertise. I really appreciate it.